particle in a one-dimensional infinite potential well. This is a very important topic for university examination point of view. Okay, in order to get equation for the energy levels of a particle moving in one-dimensional infinite potential well, first of all we need to consider a potential well. Okay, now this is a potential well. Listen carefully, this is a potential well. So this is a dimension, x dimension, and we are going to consider energy on the y-axis. Now inside, now this is called as potential well. This is called as potential well. Okay, this potential well has two boundaries, that is x is equal to 0 is one boundary, x is equal to a is another boundary. So this well has limits. X is equal to 0 is the first wall and x is equal to a is another wall. So between these two walls, from x is equal to 0 to x is equal to 0 to x is equal to a, one particle is there. This particle is moving like a wave between the walls of the potential well. Okay, whenever this particle is moving forward and backward, now we have to get equation for the wave function of the particle, and also we need to derive energy levels of the particle while it is traveling from one boundary to the other boundary. That is our concept today. Now to derive equation for this particle in a one-dimensional potential well, we have to get equation known as Schrodinger time independent wave equation, that is d square psi divided by dx square plus 2m by h cut square into e minus v into psi is equal to 0. It is a equation number 1. This is called as Schrodinger time independent wave equation. How to get this equation? You can go back my presentations, you can get a clear idea about this derivation. Now in this expression, already I explained in the previous classes, psi is known as wave function of a particle. Psi is a wave function of particle moving like a wave, and x is a dimension. X is a dimension. It is also called as direction of the particle. Here the particle is moving along the x dimension, so I am using x. So after this one, m is the mass of the particle moving like a wave according to de Broglie's theory, and h cut is the Planck's constant. H cut is equal to h by 2 pi, and capital E is a total energy. Capital E is a total energy, and capital V is a only potential energy. This is about the complete description of the Schrodinger time independent wave equation. If you don't know about this terminology, it is better to understand clearly. Now to get equation for the particle in a one-dimensional infinite potential well, first of all I am considering a particle. This particle has mass m. This, where is the particle? Particle is moving inside of the potential well along the x dimension. So this well has two limits. X is equal to 0 is the first limit and x is equal to a is the second limit. Between these two limits, the particle is moving forward and backward. Whenever the particle is inside of the potential well, whenever that particle is inside of the particle is potential well inside. When the particle is potential well inside, whenever the particle is inside the potential well, that particle has zero potential energy. Now you need to substitute potential energy is equal to 0 in equation number 1. Now what will you get here? D square psi divided by dx square plus 2m divided by h cut square into E minus the place of potential energy I am using 0. Why 0? The particle is moving inside of the potential well. When it is inside, it has 0 potential energy. So I am substituting 0 in the place of V. Then after substituting 0, I will get this equation like this: d square psi by dx square plus 2m divided by h cut square into E into psi is equal to 0. Now in this expression, in the place of 2m E by h cut square, let us consider 2m E divided by h cut square I am using in the form of k square. So where 2m E divided by h cut square is there, I am using k square, where k is a propagation vector, already we know it. Okay, let us say this is the second equation. Now use second equation in the first equation. Understand carefully, this is completely mathematical concept, very important for examination point of view. So d square psi divided by dx square plus k square into psi is equal to 0. It is a third equation. Now in this third equation, it is looking like a second order. Now I am rewriting. If you have any doubt, you can ask me in the form of comment, and you can I will explain your doubt. Now in this above equation number 3, it is looking like a second order differential equation. For this differential equation, it has one solution. Second order differential equation. So for this equation, we need to get a solution. So the solution is written. I am writing solution for the second order differential equation, that is equation number 3. Solution is I am writing here. So left hand side is psi of x is equal to a into sin kx plus b into cos kx. This is equation number 4. How you got equation number 4? Equation 4, how you got? For this equation number 3, it is in the form of second order differential equation. Using the differential equation concept what we studied in your lower classes or mathematics subject, I am writing solution for the equation 3. It is in the form of psi of x is equal to a into sin kx plus b into cos kx. This is a solution of the equation number 3. Now we need to derive further. Okay, now I am writing here the solution. I am writing here once again solution of equation 3. I am writing once again here psi of x is equal to a into sin kx plus b into cos kx. This is the fourth equation. Now in this fourth equation, we have to apply, very important question it is, we have to use the conditions. In the conditions, we are applying first boundary condition. What is the first boundary condition? When the particle is at starting point, that is equal to x is equal to 0. When the particle is at the starting point, then we need to substitute x is equal to 0. Then wave function of the particle is also is equal to 0. Now substitute this condition in the equation number 4. So what I will write here, left hand side psi of x is equal to 0, right hand side a into sin kx x is equal to 0 plus b into cos k into 0. Again 0 is equal to 0 and anything 0 plus b into cos 0 becomes 1. So what I got by substituting the first boundary condition, I got b is equal to 1, b is equal to 0. Okay, now let us say this is a fifth equation. Now what we have to do? Substitute fifth equation in the fourth equation. Okay, now what I will get? Psi of x is equal to what I will get? A into sine kx. Let us see, it is a sixth equation. After writing the sixth equation, now we need to substitute. Now we need to use the second condition. What is the second condition? Where is the particle? At the ending, that particle has to reach the other limit, that is equal to x is equal to a. Now substitute x is equal to a in the equation number 6, and what I will get? Left hand side is equal to psi of x is equal to right hand side sine a into sine ka. When x is equal to a, in substituting equation number 6, here wave function psi of x is equal to 0. This kuda 0 avutundi. So I will explain you in clear once again. So now we have to substitute. What we have to substitute? X is equal to a. X is equal to a is a second boundary condition. So by substituting second boundary condition is x is equal to a, then we can get that psi of x also. By substituting x is equal to a, we can get psi of x also 0. Now use this condition in the sixth equation. Now left hand side is psi of x is equal to 0. Right hand side I will get a into sine ka. Now a will come to this side, we will get 0 is equal to sine ka. In the case of sine, when we can get 0? Sine n pi is equal to 0. Now in the place of 0, I am writing sine n pi is equal to sine ka. Sine n pi is equal to sine n ka, where n is equal to 1, 2, 3 and so on. Now remove sine function on both sides. What I will get? N pi is equal to ka. Now I need equation for the k. K is equal to what I will get? K is equal to n pi by a. This is equation number 7. Now what we have to do? Substitute the seventh equation. Now I will go to the another slide. I am writing, this is a very lengthy concept. Now I am using the equation 7. What is equation number 7? That is k is equal to n pi by a. K is equal to n pi by a. This is equation number 7. I am writing once again. Okay. So k is equal to, listen carefully, k is equal to n pi by a. This is a seventh equation. Now I am using the seventh equation in which equation? We go to the equation number 2 is there. Equation number 2. What is equation number 2? K square is equal to 2me divided by h cut square. So equation number 2 I am writing here. What is equation number 2? Equation number 2 is k square is equal to 2me divided by h cut square. This is equation number 2. Now what we need to substitute? Seventh equation in the second equation. What I will get here? K is equal to k n pi by a. So I am substituting there n square pi square by a square is equal to right hand side 2me divided by h cut square. Okay. Now I need equation for the energy of the particle. So write equation for E. So remaining things I am sending to the left hand side. So h cut square divided by 2m into n square pi square by a square is equal to E. Now I am rewriting the expression. Left hand side is E, right hand side I am writing h cut square by, I am rewriting, this is h cut, listen carefully. This is a very important concept. Definitely it will come to the exam. So E is equal to, I am writing here, h cut square divided by 2m into n square. This is a pi square by a square. Now already we know that h cut is equal to h divided by 2 pi. Substitute in the above expression. What I will get, will write step by step. Write in your notebook all the equations properly and understand clearly. If you have any doubt, you comment me. Okay, I will explain you once again. Okay, now I am substituting in the place of h by 2 pi h cut. So left hand side is energy E is equal to, in the place of h cut, so I am using h square divided by 4 pi square into 1 divided by 2m into, I am writing n square pi square by a square. Now in this expression, what happened? Check clearly. This pi square will cancel. After cancelling these terms, rewrite the remaining terms. Energy of the particle E is equal to n square h square by, here 4, here 2, 4 2s are 8 m a square. Now this is the energy of the particle. E is equal to n square h square by 8m a square. The same equation, and the place of E, I am writing E suffix n is equal to n square h square divided by 8m a square. This is a equation for the energy of the particle moving in a one-dimensional infinite deep potential well. This is a equation number 8. Now in this equation number 8, n is a energy level number. N is energy level number. We can use n is equal to 1, 2, 3, 4 and so on. H is equal to Planck's constant. We know that value 6.625 into 10 power minus 34. M is equal to mass of the particle. And what is the meaning of A? A is the width of the potential well, where A is the width of potential well. Okay, write the equations properly in your notebook and understand clearly. Now we have to substitute n is equal to 1 in the equation number 8. What I will get here? So left hand side is E1 is equal to right hand side 1 square into h square by 8m a square. So I am rewriting once again. E1 is equal to h square by 8m a square. Similarly, I am using the I am using the another, you can substitute n is equal to 2. N is equal to 2. What you can get here, I will once again, this is a heading already. I mentioned the dependent, so don't bother about this equation. So now we are discussing. Now we are what we are going to discuss. We are going to once again. Now this is not Schrodinger time. Independent with dependent wave equation. Now we are in the discussion of particle in a one-dimensional potential well, but heading is wrongly printed, so no need to consider. No need to consider this one. Okay. Now we need what we need? We need equation for the particle in a one-dimensional potential well. Now this is not, this is one. We need to derive equation of the potential well. Now we need to substitute n is equal to 2 again. N is equal to 2. What I will get? Left hand side is E2 is equal to 2 square into h square divided by 8m a square. So this is equal to 4 h square divided by 8ma square. Now in this expression, in the place of h square by 8ma square, I can use E1. I am rewriting the equation like this. So E2 is equal to, what I am writing here, 4 into E1. Now we can substitute n is equal to 3. What I will get? E3 is equal to 9E1. Now substitute n is equal to 4. E4 is equal to, so 16E1. Like this we can write n is equal to n. What I will get? E suffix n is equal to n square into E1. If we can use n is equal to n plus 1, what I will get? En plus 1 is equal to n plus 1 whole square into E1. Okay, now I need to find difference between the n plus 1th energy and n plus enth energy. So what I am going to do, I need to subtract here En plus 1 minus En is equal to, I am rewriting here, n plus 1 whole square into E1 minus n square into E1. Now in this expression we can bring E1 as common. I am rewriting here En plus 1 minus En is equal to, we can bring E1 as common, remaining one is n plus 1 whole square minus n square. Now simplify this expression. Right hand side is E1, a plus b whole square, a square plus b square plus 2ab minus n square is there. Now in this expression, plus n square minus n square will cancel, and what I will get here, 2n plus 1 into E1. Okay, this is a energy difference, that is En plus 1 minus En. Energy difference between the two levels is the form of 2n plus 1 into E1. Now this is very important and lengthy also, you need to be patient. Now I am writing here, this is energy level diagram. Now this is n is equal to 1, what I will get? E1 I will get. Now I am substituting n is equal to 2, n is equal to 2, what I will get? I will get 4 into E1. If we can use n is equal to 3, I will get 9E1. like this. This is called as energy levels of the particle moving in one dimensional infinite potential well. Now we need to get equation for the wave function. To get once again here also this is wrongly printed, so no need to consider, this is not this one, so heading is wrongly printed, so no need to consider this one, Now what is our concept? We need to derive equation for the wave function. Now this is still somewhat pending. We need to get wave function of the particle, we need to derive. Okay, therefore what we have to do, we need to write some more steps here. Now already we discussed up to now, we got one equation. What is that equation? Psi of x is equal to, we got equation for k. Where is the meaning of k? Listen carefully and understand properly. Now we got eigenfunction, we need to derive eigenfunction. What is the meaning of eigenfunction? Psi of x is equal to 0, we got. Now listen carefully, this is equal to k is equal to n pi by a. This is a 7th equation. Now substitute 7th equation in the 6th equation. Now substitute say equation 7 in the equation 6. What is equation number 7? I am rewrite going back. What is the meaning of equation 7? K is equal to n pi by a. K is equal to n pi by a. It is the 7th equation. Okay. Now what is equation number 6? 6th equation is psi of x is equal to a sin kx. 6th equation is psi of x is equal to A into sine k into x. This is equation number 6. Okay. Now what we have to do? Substitute seventh equation in the sixth equation. So what I will get? Psi of x is equal to A into sine k means n pi by a. Say k into k is equal n pi by a into x. This is equation number. Equation number is ninth equation. This is equation number 9th. Okay. Now we need to find a value. Now to find a value, we need to apply normalization theorem. Okay. So what is the normalization theorem? Wait for 1 second. So we need to derive normalization theorem is the total probability of finding the particle, within the well is equal to unity. That is called as normalization theorem. Now we need to find the value of a in the equation number 9. To find a value in equation number 9, we need to use one theorem that is called as normalization theorem. According to the theorem, the total probability of finding the particle within the well is equal to unity. According to that theorem, I am writing here integral 0 to a, probability means px dx is equal to integral 0 to a modulus of psi of x square into dx. This is called normalization theorem. Okay, very important for the 2 marks. Okay, now this is from the normalization. According to the normalization, the total probability of finding the particle within the well is equal to unity. According to this theorem, I am writing left hand side is equal to 1 and right hand side I am writing integral 0 to a. The place of psi of x I am using the equation number 9, that is equal to a into sine n pi by a into x in the modulus square into dx. Now a square is a constant, it comes outside. Left hand side is 1 is equal to a square into integral 0 to a sine square n pi by a into x into dx. Now after simplification of this integration, what I will get? A is equal to root of 2 by a. A is equal to root of 2 by a. This is a 10th equation. Now substitute 10th equation in the 9th equation. What I will get? Psi of x is equal to, the place of a I am writing root of 2 by a. Root of 2 by a into sine n pi by a. This is a equation. This is a equation known as eigen function. This is the equation called as eigen function of the particle moving in the one-dimensional infinite potential well. This is completely